This is Pre-Algebra Lesson 42, Compound Probability with and without replacement. Today's objective is to determine the probability of compound events occurring that are either replacing or not replacing items. If you remember from our study with compound probability, that's when more than one event is occurring at the same time or simultaneously. We're looking at what would happen to the total number of outcomes when we either replace an item or don't replace an item. For instance, when we're replacing marbles into a bag after choosing one or two from that bag. So when we replace the item into a bag, what would happen to the total number of outcomes for each event? That's right, it does not change. Okay? Now, if we choose an item from the bag and not replace it, what would happen to the total number of outcomes? It does change. So therefore, replacing an item keeps the total number of outcomes exactly the same. But if we do not replace it, our total number of outcomes does change because we no longer have the same number to choose from. Pause and copy this into your notebook. Okay, let's look at some practice problems. In our first example, there are 8 red marbles, 5 blue marbles, and 3 yellow marbles, all in a bag. Without looking, Paul picks one marble from the bag, replaces it, and then he picks a second marble. We want to know what the probability is that Paul will pick a red marble first and then a yellow marble second. All right, well, when we're looking at this, again, we're looking for the probability of picking a red times the probability of picking a yellow. Our total number of outcomes is the 8 red, the 5 blue, and the 3 yellow. So therefore, our total number of outcomes is 16. Okay, so the probability of picking a red is 8 out of 16, or 1 out of 2, 1/2. If we are going to replace the item, we want to know what would be the probability now of choosing a yellow. Well, there are 3 yellows, and our probability remained the same, which is out of 16. So it's 3 out of 16. And now we're going to multiply these together. So we will now get 3 out of 32 as our final probability of getting red first and yellow second. In our next example, Lena has a drawer that contains 10 white socks and 8 pink socks. Without looking, she picks a sock from the drawer. What is the probability that she will select a white sock on both of her picks? So again, we're looking to pick white socks. So in this situation, she's going to pick 2 socks. So we're going to have 2 choices, and we're looking for the probability of getting a white on the first one times the probability of getting a white on her second draw. Well, the total number of outcome is 10 and 8, so it's 18. All right. So if we want to get a white and a white, to get a white the first time, it's going to be 10 out of 18. If she gets that white, she's not going to put it back because her goal is to pick a pair of white socks. So therefore, she no longer has 10 white socks left over. She now has only 9 white socks left over. And if she kept out the first one because she wanted to make a pair, she no longer has 18 total outcomes. She now has 17 outcomes to choose from. Okay, well, you're going to go ahead and find the answer to this. Pause and find the answer to this problem. I would solve it by using cross multiplication to simplify my problems earlier. 9 goes into 18 2 times, and this becomes a 1. Now I can simplify it further because 2 can go into 10 5 times. So now I have 5 times 1, which is 5, and 1 times 17, which is 17. So the final answer is 5 out of 17. Now, of course, there are other ways you can do it. You can simply multiply straight across and get 90 out of 306, and you would simplify it. But when you get down to your final simplification number, you would end up with eventually 5 out of 17. Find a way that makes the most sense to you to do the problem. Okay, in our next problem, we have a word problem. These are always fun. I love these. Addie lives in Collinsville, Virginia. She wrote each letter of the word Collinsville on a separate card and put the cards in a box. Without looking, she chooses a card and kept it. Then her friend Mitchell reached into the box and chose a card without looking. What is the probability that both Addie and Mitchell chose cards with the letter I? All right, so we're looking for the probability of getting an I times the probability of getting an I. So identifying what we're looking for to begin with. Our total number of outcomes are the total number of letters in this word Collinsville. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 as our total number of outcomes. So what is the probability of getting an I the first time? Well, there's an I and there's an I. So there's 2 out of 12. Now our goal is that they both wanted to get the letter I. So for the second letter, are we still having 2 out of 12? Again, keywords in our problem say that they kept the letter. All right, so therefore we no longer have 2 I's left over. Now we only have 1 I left over. And because we kept a card out instead of 12, we now have 11. All right, we want to find the total probability. I personally would simplify and make this 1/6 times 1 out of 11. And the final answer would be 1 out of 66. Hopefully that is the answer you found as well. All right, here are the 2 problems for the U-turn page. Copy the problem, all of the words, and then find the probability. Please put it in lowest terms, showing all of your work. Good luck, and I'll see you next time.